Hello everyone, welcome to this video. In this video, we are going to solve question from June 2018 consisting of 4.75 marks. The question is, the admissible extremal for j of y, which is given to be integration from 0 to log of 3 e to the power minus x y dash square plus 2 e to the power x y dash plus y dx, where y at log 3 is 1 and y of 0 is free, is which of these? So we need to suggest which among these four is the extremal of the given functional. So this question is different from the ones we are solving earlier. Here you have the left boundary as free, left free boundary, and the right boundary in our question is fixed. Right? Yeah. So for solving such question, what should be our approach? Firstly, we should solve the Euler-Lagrange equation, which is the necessary condition to get extremum. What is that? That is f of y minus d dx of fy dash is equal to 0. Moreover, if our end point is free, here you can see that y at the point 0 is free. So that means they have specified x is equal to 0 is fixed and y can have any value. So what is that? It can have any value among this y axis, right? So we can say that our extremal could move, say this is log of 3. So extremal could have any values like this. So in this case, the extra condition that would be required to solve this would be f of y dash at the point, this left boundary, at the point x is equal to 0 is 0. In some cases, there is another situation. Let us see that also. Suppose this log of 3 is fixed and here you have some other line, say some horizontal line. So in that case, what your extremal could be? For that, you have another condition, that is f minus y dash fy dash at the given point, whatever the point is x1, is 0. So this condition should be used. Moreover, if your one end point is extremely free, is absolutely free, and the second is fixed, in that case you can use both of these conditions, that is fy dash at that point x1 is 0 and f minus y dash fy dash at the point x1 is 0. So both of these conditions should be satisfied. One more case is there. If you they have specified that your extremal moves on a certain curve, say this. If the left end point is moving along a certain curve or a right end point is moving along a certain curve, then in that case your conditions, that is they are known as transversality conditions, are specified. What are they? They are f plus psi dash minus y dash fy dash at the point specified, say x2 is 0 if this is psi and this is phi, and another condition is f plus phi dash minus y dash at fy dash at the point x1, right, is equal to 0. So anyway, in our question these are not required, so let us focus on these two conditions as of now. So let us get started with the solution. So first of all, Euler's equation must be solved. So our f is this. What is our f of y? In this term there is no y. There is no y here. Here is y. So our f of y is 2 e to the power x minus d dx of f of y dash. F of y dash would be 2 e to the power minus x y dash, and from here it is plus 2 e to the power x is equal to 0. So you can take 2 common, so we are left here with e to the power x minus here we have to apply the multiplication rule. So that would be minus e to the power minus x into y dash plus e to the power minus x into y double dash, and here we have e to the power x is equal to 0. So this cancels with this, so we are left with e to the power minus x y dash minus y double dash is equivalent to 0. Now you can say that e to the power minus x, whatever is the power of e, that this cannot be 0 because we know exponential function is never 0. So we have y double dash minus y dash is 0. In operator form, we can write this equation as d square minus d is equivalent to 0. This gives us d is equal to 0 and 1. So the corresponding functional y would in this case would be y of x, that is equal to c1 plus c2 e to the power x. So now we must find what these constants c1 and c2 are. So at left boundary, that is at x is equal to 0, we must have this condition that fy dash is 0. Fy dash at the point x is equal to 0 is 0. So what is fy dash? Fy dash is simply this, right? Or you can again calculate it. So it is 2 e to the power minus x y dash plus 2 e to the power x at x is equal to 0 is 0. So from here, what is y dash? If you differentiate this curve with respect to x, you will get c2 e to the power x. So let us substitute the values. We can take 2 common. So it would be e to the power minus x. Y dash is c2 e to the power x plus e to the power x. At the point x is equal to 0 is 0. Right? So here you get c2 plus e to the power x at the point x is equal to 0, 0. And when you substitute it here, you get c2 plus 1 is equal to 0. So c2 is equal to minus 1. So we obtain one constant from here. So let us calculate the another constant from the given condition. The given condition is y at log 3 is 1. So let us substitute it in our extremal. So our extremal now becomes y is equal to c1 plus what is c2? c2 is minus 1. So we have minus 1 e to the power x. What was our condition? Our condition was y at log 3 is 1, right? Y at log 3 is equal to 1. So we have 1 is equal to c1 minus e to the power log of 3. So c1 minus 3. So you get c1 is equal to 4. So our y now becomes 4 minus e to the power x. So this is our answer. This is our extremal. So let us see what is the correct option. So the correct option is A, 4 minus e to the power x. I hope you like this video. Please like, share and subscribe to the channel. Thank you for watching.